Hello everyone, I'm Lelouch V. Britannia, and in today's video, H and I are going to talk about gas laws. There are 5 parts in this video, with each part containing different topics. The first, third, and fifth part will be handled by me, and the second and fourth part will be handled by H. There are 3 characteristics of gas that will be talked about in this video, which is pressure, temperature, and volume. In this first segment of the video, I will briefly explain about the pressure, temperature, and volume of gas. First, I will explain about the pressure of gas. Pressure is the force exerted by gas particles colliding with the walls of their container. It usually measured in atmospheres, atm, pascals, pa, or millimeters of mercury, mmHg. Higher pressure means more frequent and forceful collisions of gas particles with the container walls. Next one on the list is the temperature of gas. Temperature measures the average kinetic energy of the gas particle. It is usually measured in Kelvin, Celsius, or Fahrenheit. Higher temperature means higher kinetic energy, causing the gas particle to move faster. Lastly, we have the volume of gas. Volume is the amount of space that a gas occupies. It is usually measured in cubic meters or liters. The volume of gas can change with the changes in temperature and pressure. And that's it for this first segment of the video. I hope my brief explanation are understandable and useful for everyone. For the next segment, H will explain about the relationship between the pressure and the volume of gas. Go ahead, H. You got to go.
What's good, everyone? H here. Today I'm going to explain the relationship between pressure and volume of gas. The relationship between pressure and volume of gas is described by Boyle's law. According to this law, the pressure and volume of gas are inversely proportional, assuming that the temperature and amount of gas remain constant. Mathematically, this can be represented as PV equal to K, where P is the pressure, V is the volume, and K is a constant. This means that if the volume increases, the pressure decreases, and vice versa, keeping the product of pressure and volume constant. This law applies to ideal gases under certain conditions. However, it's important to note that Boyle's law applies only to ideal gases under specific conditions, such as constant temperature and the absence of intermolecular attraction. As the condition change, other gas laws such as Charles' law and Gay-Lussac's law may also become relevant. These additional gas laws help account for how temperature, pressure, and volume are related in the behavior of gases. Now, let us look at photograph 4.4. Photograph 4.4 shows an exercise ball being compressed when someone sits on it. What happens to the air pressure inside the ball? When someone sits on a compression ball, the air inside the ball experiences an increase in pressure. This is because the mass of person sitting on the ball applies force on the ball, which in turn exerts pressure on the air inside the ball. As the person's weight pushes down on the ball's air becomes more compressed, leading to an increase in pressure within the ball. The air molecules are forced closer together due to the compression, resulting in an increase in the pressure exerted by the air on the walls of the ball. With that said, that's all from me.
Oh, hello there, we meet again. And before I forgot, thanks H for the explanation. Now we are already at our last segment of the video, where I will explain about the relationship between volume and temperature of gas. First of all, we are going to look at the textbook, this one right here. As we can see, this empty plastic bottle right here shrink after being cooled in the fridge. So what happened here? Well, when you put an empty plastic bottle in the fridge, the volume of air inside the bottle decreases. This is because the air inside the bottle cools down, causing the gas molecule inside the plastic bottle to contract and occupy less space. Anyway, let's get back on our main topic. So, the relationship between volume and temperature of gas is described by Charles' law. This law stated that for a given amount of time for gas at constant temperature, the volume of gas is directly proportional to its absolute temperature. Mathematically, Charles' law can be expressed as V proportional to T, or V1 over T1 equal to V2 over T2, where V1 and V2 are the initial and final volume of the gas, and T1 and T2 are the initial and final temperature of the gas. Next, I'm going to talk about direct proportionality between the volume and the temperature of gas. As the temperature of the gas increases, the volume also increases. Conversely, if the temperature decreases, the volume also decreases. Next, I will explain about absolute temperature. When measuring the temperature of gas, we must measure it in Kelvin, because the Kelvin scale starts at absolute zero, the point at which gas particles theoretically have no kinetic energy. To convert the temperature from degrees Celsius to Kelvin, use this equation, where we must add 273 to the degrees Celsius that we want to convert to Kelvin.
Welcome back everyone. Let's move on to the next subtopic, relationship between pressure and temperature of gas. The relationship between pressure and temperature of a gas is described by the ideal gas law, which stated that the pressure and temperature of a gas are directly proportional. Mathematically, this relationship can be expressed as PV equal to nRT, where P is the pressure, V is the volume of the gas, and N is the number of moles. R is the gas constant, and T is the temperature in Kelvin. Simpler terms, as the temperature of gas increases, the pressure of the gas will also increase, assuming the volume and number of moles remain constant. Conversely, as the temperature of a gas decreases, the pressure of the gas will also decrease, assuming the volume and number of moles remain constant. The Gay-Lussac's law, also known as the pressure law, stated that the pressure of a given quantity of gas kept at a constant volume is directly proportional to its absolute temperature. Mathematically, this relationship can be expressed as P1 over T1 equal to P2 over T2, where P1 and T1 represent the pressure and absolute temperature of the gas at one state, and P2 and T2 represent the pressure and absolute temperature of the gas at another state. Now let's refer to photograph 4.6 and photograph 4.7. Photograph 4.6 shows air pressure in the tire of a car being measured on a hot day. The driver of the car touched the tire after the journey and found that the tire is hotter than before the journey. Photograph 4.7 shows the reading of the pressure gauge before and after the journey. What happened to the air pressure inside the tire? On a hot day, air molecules in the tire expand and become more energetic as the temperature increases. When the driver touched the tire and found it to be warmer, it suggests that the air inside the tire has expanded due to the higher temperature. According to the gas laws, an increase in temperature typically results in an increase in pressure. Therefore, the air pressure inside the tire likely increased as the air molecules within the tire expanded and become more energetic due to the heat. With that said again, that's all from me. H signing off.
Hello everyone, I'm back for this last part of the video. In this part, we will do problem solving involving pressure, temperature and volume of a fixed mass of gas using formula from gas law. A syringe contains 50 cubic centimeters of air at a pressure of 110 kilopascal. The end of the syringe is closed and its piston slowly pushed until the volume of the air becomes 20 cubic centimeters. What is the pressure of the compressed air? After analyzing this question, we can get that the initial volume and pressure of the gas are 50 cubic centimeters and 110 kilopascal respectively. The final volume of the gas is 20 cubic centimeters, but the final pressure are not given. The question asks us to find the value of the final pressure. To solve this question, we must use Boyle's law using this formula. After inserting the information that we get into the formula, we will get this. After a simple calculation, we get the answer, which is 1275 kilopascal. An air bubble trapped under a leaf in a lake has a volume of 1.60 cubic centimeters at the temperature of 38 degrees Celsius. Calculate the volume of the bubble if the temperature of the water in the lake drops to 26 degrees Celsius. From this question, we get that the initial volume and temperature of the air bubble is 1.60 cubic centimeters and 38 degrees Celsius respectively. The question also gives 26 degrees Celsius as the final temperature with the final volume of the air bubble missing. The question wants the final volume of the air bubble. To solve this question, we must use Charles' law using this formula. After inserting the information that we obtained into the formula, we will get this. After a little bit of calculation, we obtain that the answer is 1.54 cubic centimeters. Pressure in the gas cylinder is 175 kilopascal at the temperature of 27 degrees Celsius. Heat from a nearby furnace causes the gas pressure to increase to 300 kilopascal. What is the temperature of the gas inside the cylinder? After reading the question, we obtain that the initial pressure and volume of the gas is 175 kilopascal and 27 degrees Celsius respectively. The question also provides us with the final pressure of the gas, which is 300 kilopascal with the final temperature being unknown. The question asks us to calculate the final temperature of the gas. To solve this question, we must use Gay-Lussac's law using this formula. After inserting the information that we had obtained into the formula, we will get this. After some calculation, we obtain that the answer is 241.3 degrees Celsius.
Well, we're glad we have reached the end of the video already. I hope everyone find this video helpful and informative. Have a good day and goodbye.